Integrated Math 3, this is your third lesson, lesson 1.03 in the unit of statistics, and this is on distributions. So, box and whisker plots. In a box and whisker plot, the data is divided into 4 parts called quartiles. Here's an example with an odd number of values. So you place the values in order, and we're just going to assume these are the values you were given, and you find the median. So in this case, the median is just a single number, 6. There's 3 numbers to the right of it, there's 3 numbers to the left of it. That makes it the median. Then you find the median of the lower half values. So in this case, the lower half is 3, 4, and 4. So the median there is that middle 4. Find the median of the upper half of values, 8, 9, and 11. The median value there is 9. So what you do then is you draw a line above the first quartile, 4 above the 6 in the middle, which is the median of the whole set, and then above the 9, which is the median of the third quartile. And you complete the number line that spans the range of the values. So draw vertical lines at the first, second, and third quartiles. And so up above, what we have is just an entire number line. So 3, 4, 5, 6, 7, 8, 9, 10, 11. Not just the numbers in the set. And you draw dots at the high and low end of the values of the range and connect these lines. And these are the whiskers. So that's how you would draw a box and whisker plot. Okay, so it goes from the lowest number and the highest number in the set, which is 3 and 11. The 12 is just there just to show the continuum of the numbers. And then you draw vertical lines, up and down lines at the first quartile, at the second quartile, and at the third quartile. Okay, normal and skewed distributions. In a normal distribution, the data is clustered around the mean, the average. The data is then distributed evenly on both sides. So we've seen that before. That's the bell curve on both sides of the mean. This produces a mean and median that are near the center of the range of the data. A normal distribution is also called a Gaussian, we haven't used that word yet, or bell curve, but usually we call it a normal distribution. Bell curve is just the shape. Gaussian distribution is rarely, at least in our class, is going to be rarely used. So there it is. You've seen this before. There's the normal distribution. 68% of the values fall within plus or minus 1 standard deviation of the mean. So that's the pink area there. 95% of the values fall within plus or minus 2 standard deviations of the mean. That's the pink and blue areas together there. And 99.5% of the values fall within plus or minus 3 standard deviations of the mean. That's almost everything, but not quite. And that's the pink, blue, and green areas that you see. Okay, skewed distribution. In a skewed distribution, the data is clustered to one side of the set. This produces a mean and median that is to one side of the range of the data. So if the high side is to the right, then it's said to be skewed to the left. What that means is you're kind of taking a normal distribution and pulling it out to the left side, so it's stretched out to the left side. The right skewed means you're taking the normal distribution and you're stretching the right side of it out and making it longer. So that's what it means. Now you can see what the relationship now is. The mode is the place where there are the most values. That's the highest point. And what you see is the mean is going to be further out to the right, and the median, this is on the right skewed distribution, and the median is going to be between the mode and the mean. On the left side, I'm kind of going backwards here, the median is in the middle and the mean is further to the left. So you can see how that relationship would be, what that relationship would be if you skewed the distribution. So left skewed means the data is dragged to the left. Right skewed means the data is dragged to the right. Okay, a skewed distribution can also be in the form of a dot plot or a histogram. So you see how that is skewed. Both of those are skewed to the right because they're dragged further to the right from a normal distribution. These skewed plots could represent earthquake magnitudes. Most earthquakes are small and fewer are large. So if you looked at that, most earthquakes are around 2 or 3 or 4, something like that. I'm not using the numbers that you're seeing there. Whereas a few of them are really big, 8 and 9. So that would stretch the curve, the distribution curve, off to the right. Okay, so give an example of a distribution skewed left distribution. Well, let's take tests in a class, test scores in a class. Assuming that most students have done their homework and they're prepared for the test, your mean from 0 to 100% is going to be maybe somewhere around 70 or 80. It's going to tend to be to the right, closer to 100 than to 0. So that would be an example of skewed left. You'd have a few students that didn't study and they got a 0 or a 10% or 20% on the test, but hopefully not very many of those. Most of them would be 70, 80, 90%. So that would cause most of the students to be on the right-hand side from 0 to 100, closer to 100 than 0, and so that would skew it to the left. And then give an example of a skewed right distribution. Well, what we just talked about, earthquakes. Most of them on a scale of 0 to 9. Most of them are around 2 and 3. They're very small. You hardly even feel them. In fact, you don't feel most earthquakes. But then a few of them are the really big ones that become famous, and that would be over in the 8s and 9s, and so that would be skewed to the right. Okay, so let's do an example here. A normal distribution has a mean of 50. That means that that highest point, mu, is right in the middle there, and that's 50. And a standard deviation of 12. That means one standard deviation to the right would be 50 plus 12 is 62. One standard deviation to the left would be 50 minus 12. That would be 38. Okay, so let's go ahead and answer some questions here. What percentage of the values lie below 62? So 62, we said, is one standard deviation to the right. It's right here in between the pink and the blue on the right. That's one standard deviation to the right. That's where 62 would be. So everything to the left of that would be the percentage of values that lie below 62. So it's the 34.13 right here, the other 34.13 right here, the 13.59 right here, 2.14 right here, and this little bit out here, the 0.13. When you add all of those up, that's the percentage of values that would be below 62%, and that would give you 84.12% when you add all of those up. What percentage of values lie above 62? Well, one thing you can simply do is you have to have 100% of the values. If you add up all of these percentages, it has to add up to 100%. So you could simply say 100 minus 84.12 equals 15.88. The other thing you could do is simply add 13.59 plus 2.14 plus 0.13, and that will give you 15.88 also. What percentage of the values lie below 74? So what does 74 represent? 50 plus 12 is 62. That's one standard deviation. Now add another 12 to that and you get 74. That's two standard deviations. So that is this line right here on the right-hand side between the blue and the green. That area right there. So the percentage of values that lie below that, that's to the left of that, is 13.59 plus 34.13 plus 34.13 plus 13.59 plus 2.14 plus 0.3, and you add all that up and you get 97.71% of the values lie below 74, which is two standard deviations above the mean. What percentage of values lie above 74? So you can simply say 100% minus 97.71% will give you 2.29. Or if you add 2.14 plus 0.13, you actually get 2.17. And the reason for that is that the numbers down here on this graph add up to 99.98. They don't add up to 100%. That's just because of rounding error, what's called rounding error. They rounded them off to 2 digits. So don't worry about those little decimal places at the end. That's okay. All right, so anyway, that's how you would make those calculations. Okay, so that takes care of this lesson. So you're going to have some of these to practice on the assignment. I'll have the assignment video up on Sunday afternoon, and you can go ahead and get this assignment done. And we'll see all of you in class on Monday. Have a good weekend.